Impedance is total of resistance in the circuit when it is given an AC signal input. The unit impedance is ohm. Impedance cannot be calculated if it is given DC signal input. It is because of there is no frequency in DC signal. If it is given an DC signal input, it will be an open circuit.
Calculate impedance. Capacitor is 1 divided S per C. Inductor is S times L. Resistor is R. With S is Laplace from G omega. Description: S is domain frequency. The impedance formula: Z is equal R plus Gx. This X can be XL equals omega L, or X can be XC equals 1 divided omega C.
Transfer function is a ratio between the magnitude of output and inputs happen in a circuit. The benefit of knowing the transfer function is to find voltage strength, current strength, impedance of input and output.
This differential equation of transfer function is ratio between voltage output and input in frequency domain.
Frequency response is the response of two-port circuit toward its frequency difference. From the frequency response, we can know the kind of filter on a circuit. One most important thing to determine the kind of filter is cutoff frequency.
So, what is filter? Filter is a combination between capacitor, inductor, and resistor in one circuit based on its cutoff frequency can block or pass the specific range of the frequency. Kind of filters. The first is band-stop filter, the second is band-pass filter, the third is low-pass filter, and the fourth is high-pass filter. What is the difference of band-stop filter and band-pass filter? Band-stop filter used to block the specific range of frequency and pass the other frequency. Meanwhile, band-pass filter used for pass the specific range of frequency and block the other frequency. The bandwidth of band-pass filter and band-stop filter influenced by a higher cutoff frequency and lower cutoff frequency. A low-pass filter used to pass all low frequency until its cutoff frequency and block the other frequency. Meanwhile, high-pass filter used to pass all frequency, start from the cutoff frequency until the higher frequency and block the other frequency. So, I will explain the formula derivation between transfer function, frequency response, and magnitude response. We have the circuit between resistor and inductor. So, the first step is we change the prisoners inside of the inductor. So, we change it to be SL, and we know the value of cutoff frequency. So, first is transfer function. Transfer function is must to be in Laplace domain. And then transfer function is V output divided V input. So, SL divided R plus SL. In here, I multiply it with 1 divided SL because I have to be the shape of this transfer function to be like cutoff frequency. We have to, the numerator must be 1. So, we have this value. The second is frequency response. Frequency response, we just change the transfer function, the Laplace domain to be frequency domain. So, we can get this value. And the next is magnitude response. Magnitude response, we just have to be make it the frequency response to be absolute price, so we can get this value. Next, we will looking for filter from the magnitude response. So in here we input the omega value is 0 and infinity, and I have the k. First, if we input the omega value is 0, then the magnitude response is 0, and then if we input the omega value is infinity, then the magnitude response is 1, then we will get the high pass filter. And the second case is if we input the omega value is 0, and we will get the magnitude response 1, and if we input omega value infinity, we will get magnitude response 0, we will get the low pass filter. So in here, after I input the omega is 0, I get 0 for magnitude response, and after I input the omega is infinity, it must be infinity, I will get it the magnitude response value is 1, and then I will get high pass filter. The next is phase response. Phase response is circuit response towards phase change. Differentiator concept is a circuit that is connected and generate an output signal that is correspond to the differentiation of mathematics. Then integrator concept is a circuit that is connected and generate an output signal that is correspond to the process of integral of mathematics.
You can see a difference from differentiator and integrator on RL circuit. And the next image is different from differentiator and integrator RC circuit.
Next, RC circuit. This circuit has component R and C, and this circuit use KVL is sigma F equals O, VE equals VR plus VC, and then VE equals I times R plus 1 C integral E dt. First, differentiator. When VE equals VR equals I times R, then VE equals VC equals 1C integral E dt. Right side dvc per dt equals 1C integral E dt, and then C change right side C dvc per dt equals integral E dt. So C dvc per dt equals I. This circuit find I or a current, so VO equals VR equals RC dvc per dt. Next, integrator. When VO equals VC equals 1C integral E dt, then VE equals VR equals I times R Use law E equals VR per R. So VO equals VC equals 1C integral VR per R dt, and then VC equals 1 per RC integral VR per dt. Next, RL circuit. This circuit has component R and L. Use the circuit KVL. Kirchhoff 2 is sigma F equals O, VE equals VR plus VL, and then VE equals I times R plus L times dI per dt. The first differentiator. When VL equals R L times dI per dt, then VR equals I times R. Use Ohm law. Find I. I equals VR per R. So VL equals L times dVR per R times dt. Second integrator. When VR equals I times R, then VL equals L times dI per dt, then VL per L dt equals dI integral VL per L dt equals integral dI. So find them. E equals VL per L. So VR equals R per L.